when a statement is written in this form, it is understood that we're using the word and. So we're just going to leave it like this. So now the question becomes, well, then how do I solve it? Well, you solve it the exact same way that you would. If this wasn't here, what would you do? Go on, you can talk out loud.
Subtract 3.
Subtract 3 and then?
Divide 2.
Divide by 2. Wonderful. Thank you very much. And what would happen if this wasn't here? What would you do?
Subtract 3.
Subtract 3 and then?
Divide 2.
Divide by 2. Very nice. So ladies and gentlemen, we're just going to do that at the same time. We're going to subtract 3 from all of them. And then we're going to divide by 2 just like we would have. So we end up with x is greater than 3 and less than 6. Okay, so next thing we're going to do, ladies and gentlemen, is we are going to graph this. So x is greater than 3 looks like this. And x is less than 6 looks like this. But we used the word and, didn't we? So what does the word and mean? It's got to be...
They're both true.
Yeah, it's got to be true for both of them. It's got to be true for both of them. So where are the values that are true for both lines?
In between them.
In between them. That's the answer, ladies and gentlemen, what's written in red. I shall not ask you to graph all of that. I did that just so you could see. I would like you to just start at 3 and go to 6, and it's everything in between. Why? Because and is the intersection. It is the intersection of the two statements. Are we good? Okay, that's the word and. Now let's go to or. Or means either the first one has to be true or the second one must be true. So, we add 3 to both sides. X is greater than or equal to 4. Here, subtract 2 from both sides. And x is less than negative 1. And then we're going to graph. So here is x is greater than or equal to 4. And here is all the values where x is less than negative 1. Your solution must either lie on this green or this blue. Those are where the solutions that make this entire statement a true statement lie. Not the intersection, ladies and gentlemen. This is what we call the union. It means or. Now, one last thing. How do you write this graph in interval notation? Do you guys remember? How do you write example A in interval notation? What's the smallest value? 3. What's the biggest value? 6. And then we have to determine brackets or parentheses.
Parentheses. parentheses.
Thank you. Because neither one, ladies and gentlemen, is included. Okay. Let's do letter B. Interval notation. Something a little different. So here's what we're going to do. We're going to do the green one first. Interval notation for the green one starts at negative infinity and goes to -1. Both of them get parentheses because neither negative infinity nor -1 is included. The one in blue, ladies and gentlemen, goes from 4 to infinity. 4 gets a bracket because it's included. Infinity does not. And then we put this little U here, which means union, or it means or. This is how you write interval notation. Whew. Okay, we ready to go on? All right. Here's what I want you to do, ladies and gentlemen. I want you to look at letter C. I want you to look at letter C, and I would like you to graph the solutions for letter C. Please graph the solutions for letter C. Remember what absolute value means. Okay? What does this graph look like? Oh, hold it closer. Oh, look at you. Very nice. Great, I got you. Ladies and gentlemen, he's got this. Okay, so what does the absolute value of 3 equals, the absolute value of x equals 3 means all the points that are 3 units away from 0. So the absolute value of x is greater than or equal to 3 means all the points that are 3 or more units away from 0, which is what he's drawn. This point is 3 units away. These are the ones that are more than 3. This one is 3. These are more than 3. So far, so good? Great. Ladies and gentlemen, now what I would like you to do is to look at each of these that we've drawn and write the inequality for them specifically. How would you write the inequality for this? And how would you write the inequality for that one? No way, are you two in the same room as each other? Yeah, nice! Alright, ladies and gentlemen, this one here, x is less than or equal to -3. This one, x is greater than or equal to 3. How many got that? All right. Okay, so that's what it is. Now, ladies and gentlemen, the solutions either lie on this line or this line, so we would write or. So the absolute value of x is greater than or equal to 3. The solution is x is less than or... hold on. X is greater than or equal to 3, or x is less than or equal to -3. That's the solution. And we found it by looking at the graph. Go back. When you have greater than or equal to, the absolute value is greater than or equal to, this will be OR. Look at this. So when we had this, the absolute value of x is greater than or equal to 3, we wrote two inequalities. Our inequalities were x is greater than or equal to 3, or x is less than or equal to negative 3. So I'm sort of going to parallel that. If you go back to the one that we had in letter D, remember when we graphed this, all the values that were less than 2 units away from 0? We had this situation. And I asked you guys, well, how do you write the solution for this? And you said, well, it's x is greater than negative 2 and less than 2. So when you're dealing with less than and you're in a confined space, it's the intersection of something that is greater than negative 2 and less than 2 at the same time. Was that a good explanation?
Yeah.
From this lesson, more than anything, you guys need to understand this. When you are dealing with OR, it is greater than or equal to. If you have a greater than or equal to absolute value, we used OR. When it was less than or less than or equal to, we're going to use AND. And hopefully, if I get through this lesson, you'll understand why you need to know these. Because we've already talked about what's the difference between the words. Now we have to figure out when do we use them. So here we go. I'm going to go back to this one, okay? Where we said, the first thing that I asked you guys to do in problem C was to graph what the absolute value of x is greater than or equal to 3 means. And you guys graphed, well, it means it's more than 3 units away from 0, so this is what your graph looked like. And then I said, that is correct. So now, when you graph this to the left is x is less than or equal to 3. This to the right is x is greater than or equal to 3. Your solutions either lie on this line or this line. That's where the OR comes from. Now this one, when we did this one, this is what the graph looked like. The absolute value of x is less than 2 looked like this graph. It's the intersection of all the values that are greater than negative 2 and less than 2. So where these two green lines intersect is the blue line here. And this is, we use the word and because it's an intersection. So, oh my goodness. Okay, so, oh my gosh, I'm sorry. My battery just said it has 5% left, so now I got to get through this. I don't know how long it's going to last. Sorry. That's what I was panicking about. So when we have greater than, we use OR. When we have less than, we use AND. Good enough? Hopefully, what you guys have learned from the first two problems that we did is that greater than or equal to, greater than will mean OR. Why? Because we're either going far to the right or far to the left. We're going away. If you have greater than, less than or equal to, this will use the word AND because we are looking for the intersection of the two inequalities that we are going to write. Everything else stays the same. Devin, you take the ACT whenever you want. You can take the ACT when you're in 8th grade if you want, and you can take it as many times as you want. They don't care. So, anyway, here we go. Let's take a look at the first one. First of all, we have isolated the absolute value, so we're good there. Now at this point, just like when we had an equation, we need to write two inequalities. Okay? So I'm going to go back here because I want you guys, where we take the expression that's in the absolute value, x plus 3, and we write greater than or equal to 5. And then we have the expression in the absolute value and negative 5. But since we're going in the opposite direction, we must change this to less than or equal to. Now, is it and or is it or? Since this is greater than, we're going in away from 0 in two different directions. This is or. And now you have to do is solve them. Subtract 3 from both sides. X is greater than or equal to 2. Or x is less than or equal to negative 8. Okay, ladies and gentlemen, you can see what I did here. I solved it, I graphed it, I put it in interval notation. If you don't understand any part of that, go ahead and let me know now. Okay, let's move on, ladies and gentlemen. The absolute value of 3x minus 6 is greater than or equal to 3. Now, once again, we want to look at our sign. This is going to help us. Greater than or equal to or. So we just have to write two inequalities. 3x minus 6 is greater than or equal to 3, or 3x minus 6 is less than or equal to negative 3. Go ahead and solve it, see what you get. Once again, ladies and gentlemen, you can speak to me privately if you don't want to speak out loud. You guys should all have your cameras on too. All right, ladies and gentlemen, questions, problems on letter F? We're good? Okay. Letter G, First thing we want to do, ladies and gentlemen, is isolate the absolute value. So we're going to subtract 6. 4 times the absolute value of 2x plus 6 less than or equal to 12. Divide by 4. The absolute value of 2x plus 6 less than or equal to 3. Now, oh, am I going too fast? Okay, ladies and gentlemen, this is less than or equal to. And remember, when less than or equal to, we're in a limited space. So this is where we have two lines that will intersect. So we have 2x plus 6 less than or equal to 3, 2x plus 6 greater than or equal to negative 3. But in this case, ladies and gentlemen, it is and. And then we solve.
Wait, I'm sorry. Why would it be and this time?
Okay, because it's less than. If you go back to, that's why we're going to use and in this case. So here's negative 9 halves. Here's negative 3 halves. And we want where it's greater than 1 and less than the other one. Negative 9 halves to negative 3 halves. That's my solution. Okay, ladies and gentlemen, questions on letter G? Does this have to be a fraction? I'm going to push you guys to use fractions because otherwise a lot of you, the only reason you guys like decimals more than fractions is because you can put it in your calculator, and you're not going to have your calculator for this, so putting it in decimals really doesn't make sense because all you'd put in your calculator is 9 divided by 2, which is a nice fraction. So I'm going to ask you to put it in fractions to leave it in fractions. Ladies and gentlemen, any other questions? Great. Last one, letter H. It's already isolated, ladies and gentlemen, so all you have to do is write two equations. Remember to use and or correctly. See what you come up with. Ready, go. Everybody ready? Ladies and gentlemen, the answer is all real numbers. Questions?
I might have missed this, but why do they not just form? Why wouldn't it be an and since they like cross over each other?
Thank you very, very much for asking. I was waiting for someone to ask because I know most of you don't understand this. You're like, look, the two lines intersect, so shouldn't it be and? Ladies and gentlemen, this is why I told you this at the beginning. This is where it stays, okay? If it is greater than, it's or. If it's less than, it's and. And now I'll explain to you why it's all real numbers. The left side of the inequality is always going to be positive, yes? The right side is always going to be negative. No matter what value you put in for x here, this will be a true statement. That's the logical explanation. The mathematical explanation is, here is the values where x is greater than 5. Here are the values where x is less than 2. Your solutions can either lie on the top line or the bottom line. So if you look at the number line, which values are either on the top line or the bottom line? And the key word is or the bottom line. Right, all of them. That's why this is all real numbers. This is why I don't want you to look at the graph and say and or, but I want you to determine before you graph that it's and or it's or. Does that make sense? Perfect. Letter E. Okay? The absolute value of x plus 3 is greater than or equal to 5. Meaning we need to go 5 units in either direction from this starting point. So, and you guys don't have to draw this. Don't draw this at all. So here's my starting point. I either go more than 5 units this way or more than 5 units that way. Are we all good with that? Is this going to be and or then?
Or.
There you go. It's or. Yep. Okay, so here's how we write. Just like when we had the absolute value, we wrote two equations. When we have an absolute value and an inequality, we need to write two inequalities. X plus 3 is greater than or equal to 5, or x plus 3 will be less than or equal to negative 5. Negative 5 because we're over here, less than because we're going in that direction. Does that make sense? Sweet. Okay, go ahead, solve it and graph it, see what you guys come up with. There's what I got. X is greater than or equal to 2, or x is less than or equal to negative 8. So close circle at negative 8, arrow to the left, close circle at 2, arrow to the right. Once again, we use the word or, which means my solutions will either lie on this line or this line. As long as it lies on one line or the other, makes it a true statement. And then at the bottom, I put interval notation, because this is the way that you guys are going to see a lot of your things on standardized tests, interval notation. Questions?
I have one.
Go ahead.
Problem. Can you go over again how you figured figured out that it was or.
Oh, okay. So I'm going to go back. Okay, so that's why I used or in this case. So you guys try the next one, letter F.
Since the 1 and 3 are in brackets and not parentheses, on E, would the -8 and the 2 also supposed to be in brackets?
Yes, you are absolutely correct. Thank you so much for saying that. These should be in brackets also. Yeah, because they're equal. Thank you. All right, ladies and gentlemen, let's do letter G. We'll do this one together because it's less than this time. First thing we want to do is isolate the absolute value. That rule still hasn't changed. So we're going to subtract 6 from both sides. Divide by 4. And I got the absolute value of 2x plus 6 is less than or equal to 3. So now we want to write our two inequalities. 2x plus 6 less than or equal to 3. 2x plus 6 greater than or equal to, because we're going in the opposite direction, -3. And ladies and gentlemen, this one's less than. So we're in a confined space. It's and. Questions, problems? Okay, you guys try the last one all by yourself, letter H. Yes, the answer is all real numbers. And you're like, oh my gosh, why? Well, ladies and gentlemen, it's the key to the word. This is what I said at the beginning when I was talking about and or, that we would see one later where hopefully this would make you understand. I'm going to show you this two different ways. Once logically and once mathematically, so hopefully you can make the connection. Mathematically, it says x is greater than or equal to -5, which means this line. X is less than or equal to 2 makes it this line. So what values on the number line either lie on the top red line or the bottom red line? That is correct, all of them. That's mathematically. Now, logically, let's go back to the original equation that said the absolute value of 2x plus 3 is greater than -7. The left side of this inequality, no matter what value you put in for x, the left side will always be positive. No matter what value you put in. The right side of the inequality will always be negative, no matter what value you put in for x. So if you think about it, the left side is always positive, The right side is always negative, so the left side will always be greater than the negative side, the right side. That's logically. Make sense? This is why I tell you guys, when you look at the problem, determine whether it's and or. Don't graph it and then say, oh, they intersect. It must be and. Gabish? Okay, in your guys' packet, you have a 1.3, 1.4 review sheet. Instead of doing the rest of the 1.4 homework, I want you guys to do the review sheet for tomorrow. Good? All right, my friends. Great job today. We'll see you all mañana. Bye-bye. Right. All right.